So welcome again, and welcome people online, especially those who are joining for the first time today. My name is Tatiana Karaulac. I'm working with Mix Global Program. I'm mainly supporting and coordinating Mix Plus surveys. And now everybody needs to ask what is Mix Plus. We will talk about it a little bit. But today we are here for another session and topic. My co-chair is Ashraf. Ashraf was here the whole day, co-chairing, chairing. So majority of you in person already met him. We will be talking about climate, conflict, and resilience. I know people in person already know about, housekeeping rules, but just quickly to remind people online that please post your questions in Q&A section. Chat is disabled. And as always, please ensure that you have your name there so you are not visible as a guest. So we know who is asking question and then to whom you are asking question. And be respectful as always. So today we have two very interesting presentations. The first one we will start with is child climate risk and resilience in Africa. And our dearly presenter is William Radgaard. William will present. We will then have a second presentation and we will have question and answer session at the end. So William, please, the floor is yours. You have 20 minutes. As previously, we will be waving to let you know that you are out of time. Here you are.
Brilliant. Thank you. Real pleasure to be here. My name is William Radgaard. I'm a senior researcher at the University of Oxford in the Department of Social Policy and Intervention. And today I'm here talking about child climate risk and resilience in Africa. This work has been developed over a couple of years and has had input from a lot of people, particularly Hernando here in the front row, Oliver Fiala, and many others in the room, Shailin, and very grateful for that.
On mute, sorry.
Thank you. and just also to mention, I suppose, in that vein, and Stephanie, of course, here at the back, and in that vein, this is very much a work in progress, and so very keen for input and feedback, and as I present the work, and I'll try and make sure that this stays open. I suppose this started with the report published in 2021 by UNICEF, which was titled, it was introducing the Child Climate Risk Index. And in that report, UNICEF estimated that around almost all children would face at least one major climate event over their life. In that same report, they acknowledged, the UNICEF acknowledged that child climate risk, as that is defined, depends both on a combination of exposure, so you may be exposed to a flood, but it also depends on vulnerability, so you must be vulnerable to that flood as well. And this is a similar sort of train of thought that's used by the Intergovernmental Panel on Climate Change and has also been adopted by a number of organizations. So following that, Save the Children published, Save the Children UK published work in 2022, which was looking at the overlap between child poverty and exposure to climate events, climate hazards globally. And I think what they found was very, very interesting, which was that really vulnerability varies greatly across countries and across hazards, and doesn't necessarily follow a single, isn't necessarily correlated in any intuitive or kind of in any way that's linear. So more vulnerable children aren't necessarily more exposed to flooding, based on the way that the analysis was put together. So I suppose kind of when we start to use this data in thinking about tools that are urgently needed in terms of kind of in terms of allocating resources to develop and child-sensitive social policy and make those services more resilient, there's this need to sort of think about how then do we use data around kind of vulnerability and also exposure to kind of inform that process. So to kind of go back to what I was saying, the Global Child Climate Risk Index that was developed by UNICEF includes both these pillars. But one of the limitations is that it's aggregated at the national level, which, if we're really trying to inform resource allocation, it really needs to be disaggregated at a lower level than just at a national level. I think, and this is kind of, I think, generally acknowledged. But to come back to that again, I think there's this, in that process, there's also a real need to kind of critically reflect on what indicator we use to measure child vulnerability. If we're overlapping risk, exposure with a measure of vulnerability, what must that be? And how do we move forward on that? So I think this is where I need my notes to make sure that I get everything right. So I think poverty is a critical determinant of vulnerability. Children that are poor are more likely to be exposed generally to hazards and have reduced capacity to cope with those hazards. And I think when we're talking about children, it's important that that indicator is age and gender sensitive. And I think based on work largely that's been led here by Dave Gordon, Shayla Nandi, that follows a human rights framework that reflects the sort of multidimensional needs of children. So based on the Bristol method that was developed here, this is sort of a bit of a summary of what is in a measure of the current international indicator of child poverty, based on the constitutive rights of the child. There are 9 dimensions, and 7 dimensions are kind of listed here on this slide. And I think as a bit of a motivator, the sort of adverse consequences of deprivation in any of those dimensions in relation to climate are also summarized on the slide. So I think at that point, the motivation for some of these dimensions for being included as in an indicator of vulnerability is worked through. Not to say that this is necessarily the final measure of vulnerability, but a lot of the dimensions that would be needed to be covered are. So based on that and moving forward with child poverty as our indicator of climate vulnerability, we were interested in overlaying that with disaster notification data to begin with. So this is the MDAT database, collects data on disasters that are either affect over 1,000 people, either where there are notified 100 people killed, or whether a country registers a national emergency. And what we did was to overlay that or superimpose that beside estimates of child poverty estimated across Western and Central Africa using mixed data and DHS data. This was all aggregated at the admin 1 level and summarized on these slides here. And what we can see is that rates of child poverty are high, especially in the central region of Western and Central Africa, in the first map. We also see that flooding is, according to the MDAT data, distributed generally across most of the region. Whereas whereas drought is concentrated in the sort of Sahel belt across the top of the region. But when we were showing these data to experts that work in kind of climate events, and they reflected that these notification data had key data gaps, and particularly in the central region of Africa, in the Congo Basin, where, according to the notification data, the number of events since 2000 are very, very low. And I think the use of this data set for kind of moving forward and looking at its relationship to child deprivation summarized in the first map was we kind of held off on that and decided to look elsewhere. We focused on satellite data that is publicly available through the Google Earth engine, which is an amazing resource, where there's data available in the Global Flood database at a resolution of 250 meters, and also in the CHIRPS database with a resolution of 5 kilometers. At this time when we were doing this work, Mix hadn't yet released the geocodes, and we really wanted to use Mix, but we had to move forward with DHS, and we will be implementing sort of the slide I showed did have mixed data in it for West and Central Africa, and we will be trying to using this method for the whole region. But to begin with, we started with Nigeria, Malawi, and Uganda, where there was a flood recorded in the year before the survey. Here, rather than using admin 1 boundaries, we used the geocoded clusters for looking at exposure to climate events. So on this slide, what we show is using Nigeria as an example, where there are clusters within 5 kilometers of the flood recorded in the year before the survey in Nigeria. 5 kilometers matches the cluster displacement and is also, I think, a reasonable assumption for the disruption to services that might be experienced in the event of a flood. And so we're quite happy with that as a buffer zone around those clusters. We also used the standardized precipitation index to monitor drought, and using kind of approaches used by the World Meteorological Association, we classify drought as at least 2 consecutive months with a standard precipitation index below 1. And I can go into more details on the SPI if people like, but those areas that are affected by drought are there summarized in brown or in orange across Nigeria here. So what we now had was a more accurate estimate of exposure. And what we found was that across countries there was high levels of exposure. In Nigeria, 6% of children were exposed to flooding, which corresponds to 5.5 million children just in that year. And in Uganda, 62% of children were exposed to drought in the year before a survey, which corresponds to over 16 million children. The overlap between these two climate hazards wasn't very large, apart from in Uganda, which I think was interesting because these climate hazards in Malawi and Nigeria were affecting different parts of the country. We also found high prevalence of child poverty across all 3 countries, and each of the dimensions of our indicator are summarized there too, with sanitation coming out as the most prevalent dimension. So here, we move on to consider exposure and vulnerability together. So I think the first thing, we've got flooding on the top table and drought on the bottom table. If you focus just on the column on the left-hand side, that's the prevalence of, I suppose, risk or vulnerability in the areas that are exposed. And those are very high. So lots of children are at risk, or are vulnerable in areas affected by disasters. And I think that's just that is important to acknowledge. And what we see is in Nigeria and in Uganda that the prevalence of deprivation is higher in those areas than the average in areas not affected by disasters, suggesting that those children in those areas are particularly vulnerable. For drought, we don't actually see. We actually see the opposite. We see that levels of vulnerability are, whilst they're still high, they're consistently lower than in non-affected areas, which is interesting. So I think then what the next step has been to try and sort of think about and process how we can then use this data for resource allocation. And on the left-hand side, we summarize a bivariate map of exposure and vulnerability. So blue is vulnerable, green is exposed, and dark green is the areas that are both highly exposed and highly vulnerable. With Sokoto and Plateau states in Nigeria coming out as particularly with particularly high levels of exposure and vulnerability. Then summarizing on this scatter plot, what's quite interesting then is to be able to kind of divide that up into quadrants where you've got more than, these are just by 50%, so more than 50% of children exposed and more than 50% vulnerable. And these circles that are drawn around those dots correspond with the top 3 quadrants on the map on the left-hand side. And I suppose depending on how this method is then used, this could be used either in preparation for increasing resilience or in following events to support coping. So I suppose what kind of as a summary of our main findings and to kind of promote some kind of discussion and really keen to get feedback on this, is that children are not uniformly at risk of climate hazards. Whilst children are generally vulnerable, vulnerability does differ, and I think it is influenced by social and economic factors. But I think there's a lot of work to be done to define how we actually measure that vulnerability. And absolutely a rights-based age and gender-appropriate indicator of child deprivation could serve as an effective measure of assessing this. But there may be, and I suppose I'll get to that in a second, and we observe high levels of child deprivation across regions, and importantly, higher levels of resolution are needed to kind of to compare exposure and vulnerability if we're to really support resource allocation. But I think there are some really important further considerations, and that leads to kind of, are the current dimensions or measures or indicators that are used for each of the dimensions of deprivation really relevant in the context of climate hazards? So for example, shelter is measured as number of children living in a house, whereas actually in the context of a climate hazard, maybe that isn't the most relevant indicator of access to shelter. And there may be other things that beyond poverty, child disability as ability to cope with climate hazards may be equally important, and living arrangements as well, particularly. And how do we consider these? And so I think there's a lot of work to be done in this area. So not just that. So we used poverty, but what we set out to measure was vulnerability, and the work by the World Bank. So we have poverty defined as a line, as a threshold, and granted, different measures don't use just a threshold approach. But ideally, vulnerability would be capturing the population above the poverty line that may be made poor as a result of this hazard. And so more thinking around how we distinguish between what is poor and what is vulnerable to poverty is really, really important in the context of climate resilience. So there's the high levels of exposure just by itself underscores the need for further investment. And these should both focus on building resilience and supporting reactive coping. And that could be through, for example, for the coping, through integration of methods like those that I've just presented with WFP's ADAM platform. I wish I could rewind back, but on that scatter plot that I showed was a large number of clusters or states in the bottom right-hand corner, which is high levels of vulnerability but low levels of exposure, which means that suddenly shifting all of our focus to climate resilience is not necessarily what's needed. What we need is continuing focus on social development and social policy, but making those services more adaptive in areas that are where exposure is high. And that is already being done through initiatives like Malawi's social cash transfer program, which has incorporated a disaster risk financing strategy, and through kind of predictive strategies at the beginning of growing seasons, which predict when there might be climate hazards that will affect crop yields, for example. So some of these findings were published in a report by the Global Coalition to End Child Poverty. So just want to make a plug for that. And just to thank everyone that's been involved in this work. And as I say, it's a continuing area of work.
Thank you so much, William. Be here for questions. I already have like 5. So next presentation is I need to read the long-lasting effects of bombing on environmental management, evidence from Kosovo. And honestly, this is something that I'm quite interested in because I'm coming from that part of the world and it's quite hot topic last, I don't know how many years. So Elda, floor is yours, 20 minutes.
Hello everyone, thank you for being here and thank you for having me actually. So my name is Ilda, I'm a PhD student at University of Reading doing a co-total program with the University of Turin at Collegio Carlo Alberto. This is work in progress. I aim to transform this into my job market paper, so please be as harsh as you can. I promise I will try not to cry, so just tell me what you think. So the reason why I decided to do this paper is that because of this region of the world is not studied enough. And doing this project, I discovered why. The data is impossible to find. The only thing that I could have is actually the mixed data, so thank you for that. And yeah, what I'm trying to do here is to basically fill a gap, because some research has been done on the impact of socioeconomic impact of war on labor, education, child development, but not that much has been done on public health and environmental in general. So what I'm doing here is try to enhance the understanding of the environmental issues, how the post-war recovery dynamics work and have affected this framework. So I'm trying to investigate the long-term effect of the war on waste management in this case and infant mortality rates in Kosovo. But first thing first, I'm not sure if everyone knows where Kosovo is. So it is here, it's this small region here, which borders with Montenegro, Albania, North Macedonia, and Serbia. The border with Serbia is shaded, because I'm not sure if anyone knows, but there has been some issues. They have declared, yeah, to make it simple. Yeah, they have declared independence in 2008, but they're not still recognized by everyone. So just to give you a timeline and a background of what happened is that before the fall of the Berlin Wall, it was somehow, some things were working, not great, but still. So yeah, the thing that I forgot to tell you is that Kosovo is plenty of Albanian people. So you have 80% of the people living there is of Albanian ethnicity. So that's why the reason they tried to become independent somehow. But before 1989, these people had, so the Albanian Kosovo people had some independence somehow. They had they had their own cultural organization and whatnot. Right after that, these organizations were shut down, and most of the Kosovo Albanian people were just put out of work. Obviously, this escalated with the Federal Republic when the Federal Republic of Yugoslavia broke up. And we have that the Albanian Kosovo people just casted a vote declaring independence and creating this Republic of Kosovo, which back then did have very little recognition. But wait, this is the framework when we first hear about the ethnic cleansing in the region, which obviously brought up the first NATO airstrike in history. Right after, we have the coming up of the Kosovo Liberation Army, which is this KLA, which obviously was not that peaceful. Whenever you respond with violence, you just have a mess. That's why we have that in 1999, this very, very dangerous, very big armed conflict started, and that's the reason why NATO intervened in March 1999, declaring it as a humanitarian war. This ended up in June, just a couple months later, 2 months and a half later, with the Yugoslavian Serb forces agreeing to withdraw from Kosovo, making way to the international presence, which as of today is still there. They're declared to not be there, but NATO peacekeepers are still there, are still present. The consequences of war were awful, as they usually are. So we had people who were killed and were missing. We have a lot of displacement, but the UN High Commissioner for Refugees told us that 76% of the people who were displaced actually came back in the region, and 94% of those who returned actually returned back in the same municipality where they were displaced from, which is huge. But as a result, we have that the region was bombed 364 times, with the capital being the most bombed. So this is just the conflict part of it. But what I promised you is waste management. So let's also talk about some waste management. Waste management is a huge issue for Kosovo and for the Balkans in general, actually. But here is that we have that 60% of the nation is affected by poor management somehow. And with poor management, I mean that 40% of the country is not even covered by waste collection. So people have just to deal with it somehow. Why? Obviously, as usual, there is insufficient cross-institutional cooperation, budget deficiencies, lack of trained staff. They also mention a lot the extensive informal sector and the weak law enforcement, again, as we always have after conflict. The odd thing is that out of the 10 landfills that were created after the war, we know the management just for 5 of them. The other 5, we don't know who needs to manage them or whatnot. Just to give you an example, one of the biggest waste landfill, which is the one in Mitrovica, which created in 1998 by the Serb forces, but was legalized by the Danish Kosovo Force, which are the NATO peacekeepers, in 2002, promising to work with it, just like manage it and make it safe, but never did. The most preoccupying thing is that this landfill is built on water pipes that provide water for a whole village. There are insurrections, there are people who complain about that, never stopped complaining about that, but nothing has been done. Another thing that is a bit preoccupying here is that these waste landfills that were constructed after the war were financed with external money. So the European Agency for Reconstruction was an institution that was basically built by the EU in February 2000 and was dissolved by the end of 2008. And they had the mandate to create this, to help Kosovo to be rebuilt, to just be back on their feet somehow. And they had a lot of autonomy. This means that they were allowed to cut bureaucratic corners to speed up the process, but obviously, I mean, this can go wrong somehow. So, what I'm doing here is trying to analyze if the violence endured during the war has affected the waste management infrastructure, potentially creating some negative externalities. How I'm doing this? Using the mixed data, the reason why we're here. We have available 2 waves of data, the one in 2012 and the one in 2018. And I focus on infant mortality. Infant mortality is not a variable which is in the data, but they ask women between 50 and 65 years old if they ever had children, when they have them, if they're still alive, and if they're not, when did they die. So given that is quite hard for a woman to forget that they have a child and they had a child who died, I think this is the most reliable thing that I can have. I also focus on the waste landfills that were opened after the war. So also the children, obviously, I mean, I consider the ones that were born after the war. And the data on the landfill were awful to get. I mean, it took me like 2 months to get a hold of this data, and not all of it was there. So for the ones that I was giving the geographic localization, everything was fine, even though I double-checked on Google Maps. They're actually there. And for the other ones, I read news articles, reports, newspaper, and whatnot, and again, double-checked on Google Maps if they were there. And everything looks fine. For the bombing, I used the Human Rights Watch data, which is the only thing that is available, and is available just at the municipality level. So just to give you some statistics, yeah, I don't know if you can read them, but the infant mortality overall is 0.028, 27-ish, which is still big. But if I look at the places that have received more bomb than the average, it is 0.032. If I look at the infant mortality of people who live within 6 kilometers of a waste landfill, it goes back to the general mean. But if I look at people who live nearby, so within 6 kilometers radius from the dump, and in a municipality which was heavily bombed, I get a 0.30. So it's 0.03. This is the reason, I mean, this is the most horrifying thing that I've got, actually. This is the infant mortality divided by municipality which was heavily bombed and low bombed before and after the opening of the dump. So before the opening of the dump, the waste landfill, we have that both municipalities had a negative tendency, so infant mortality was decreasing. Right after it opens, it just goes up. And it is more powerful, I mean, it's way higher for the regions that were heavily bombed with respect to the ones that were lower bombed. Yeah, I mean, this one is just the 2 years average infant mortality. This is just the rolling window, so it's the same, it's just the different smoothing. What I'm doing here, I mean, the analysis that I run is just a simple difference in difference restricted to within 6 kilometers first. So I just look at people who live within 6 kilometers from the dump, either if they were heavily bombed or not heavily bombed. Then I relax the 6 kilometers restriction, putting it as an interaction. That's why we have a triple difference in difference, but still limiting it to a 10 kilometers radius. So we're not comparing things that are very different from each other. Just to give you a visual idea of what we're doing here. This is Kosovo. The borders are the municipalities. The white municipalities are the ones that had a lower bombing, and the red ones are the ones that were affected by more bombing. The blue dots and the light blue dots are the clustering interviewing clusters. And then we have that this brownish dots are the location of the waste landfill. The first radius is the 6 kilometers one, and this other one is the 10 kilometers. So this is all the data that I got from here, actually. The reason why I stop at 6 kilometers is that I saw that smoothing it, this is non-parametrical smoothing. I saw that after 6 kilometers it's flattened somehow, and then it decreases up to 10 kilometers. I ran also a Callaway-Santana event study, and I can see there is a very positive and significant post-treatment effect. So as you can see how the pre-treatment is quite stable, though, I mean, the standard errors are large because the data is limited, but you can see that we have a significant effect on the post-treatment. I also try to play around with not being closed and being high bombed, and not being closed and not being bombed. I mean, everything is coherent here. But here are the main results, basically. So this is the triple difference in difference, and this is the simple difference in difference. They all consider they all include covariates and birth year fixed effects. The first column has all the data that I have. And I can see here that the coefficient is 0.032 percentage points. These are percentage points. Where the mean of the infant mortality is 0.0287. So as you can see, it's a very important effect. This is for all the data. In the second column, we have the one that has been externally funded. So we have basically just restricting the analysis to the people who live close to the waste landfill that were funded through the European Agency for Reconstruction. If I exclude that, I find no effect. So the third column is just all the other waste landfills. I have about the same with the simple difference in difference, restricted at 6 kilometers. And I mean, considering that here I have no effect, and this is the main effect, I think that this result, the overall result, is mainly driven by the one that have been externally funded. So I was looking at if this was consistent, and whatever I do, if I not include covariance, if I include whatever kind of fixed effects, this still remains the same. So it is, I would say, it's robust. Both for the triple difference in difference, I mean, it varies a bit with the coefficient, but it's about the same magnitude. It varies more with the simple difference, focusing on the 6 kilometers. But I mean, here I have the main, the bigger value here, considering the childbirth effect fixed year. Childbirth effect fixed year. No, anyway, you got it. So I was trying to understand what caused this, and I mean, the thing that we have a mix is water samples. So I was looking if these waste landfills are constructed in a bad way, there might be some infiltrations that are actually causing damage. The only thing that I could find here is in the mixed data is the water samples, and just for the one run in 2019. So I'm doing that. I ran a basic regression with the same regressors as before, so with high bombing and the interaction between high bombing and close. So whether they live within 6 kilometers from the dam and have received higher bombing number. And I also do a Poisson model on that. If I run just ULS, I find no effect, but with the Poisson level is always, with the Poisson regression is always significant. Oh, no. And it's here and here. And depending on the external or internally funded, I can see that the external funded are the ones that have a higher count of blue colonies, this Crickey-Collie count here, which is more horrifying with the spring water, the ones that comes from underground. While if I just focus on the internal funded, I see that the wells are the most affected ones. But still not as huge as the spring water one. So again, there might be some infiltrations here. The other, I mean, this was one of the channels. The reason why I think this happened is mostly because of corruption. I mean, money came. There is money. So the European Union funded this. Also, money came from the US aid program. So it's not an issue about money or people who you can pay to get this done properly, right? I'm afraid there must be some kind of corruption. So I just got a hold of this UNDP data, which analyze. I mean, they actually ask questions on the perception of corruption. Here I focus on the corruption on local government, central government, and international organizations. And again, I run the same regression as before with high bomb if they live in a region, if they live close to the waste landfill, and then the interaction between them. And I can see actually that the places that have received higher bomb and have a wasteland in their proximity think that the local government are more corrupt with respect to the other ones. But if you look at the central government and the international organization, it is not true. It is negative. So they think they have less corruption with respect to the others. This is not true if you divide it in the externally funded and the internally funded. Again, both of them think that their local government is corrupt, but whoever has had an externally funded waste landfill is way more convinced that their municipality is less corrupt. The opposite happens with the international organizations. So, I'm still, again, this is still work in progress. I'm still trying to understand what this means. But again, I mean, the two samples look about the same. So I'm afraid that I will still need to understand how to frame this nicely. I'm also looking at data on, I'm looking at two things actually. I'm looking at data on voting to see if there is some particular political party which determined this. And I'm also looking, I still have a few seconds? No? Okay.
5 seconds.
Okay. This data set also asks if they had, if they lived some human rights violation during the war. So that is the next step, understanding if these people who actually think that the government is more corrupt has less violence, because I'm afraid that whoever has endured more violence could be more lenient toward corruption and then just be more easy on this kind of behavior that caused also the improper building of the wasteland field. That's it.
Give me a mic as they close.
Sorry. Yeah.
Thank you so much, Hilde. Okay, we have, I think, 15 minutes, if I'm right. Am I right? For questions? Sit. Yeah, sit there.
Yeah.
So I'm asking people in the room if any questions for first or second presentation. Ron?
Yeah, sure. Thank you so much. Wonderful presentation, both. Thank you for the last presentation. I was wondering, I think that the water regressions are the very important to explain the treatment effects probably, but I am not sure why did you choose an OLS, because it's a Poisson or a negative binomial, but I don't know also why did you show both, because if there is over dispersion, you should be showing only one, right? And that's my doubt. And also I was thinking that in that case, I don't know the data, but I suspect that it's a zero-inflated negative binomial or a zero-inflated Poisson more appropriate, but it's something maybe you can test, because I don't know how many zeros are there in the data, but I suspect that it could be the case. It's just a comment and a curiosity. Thank you.
Any more hands? Oh, yeah.
Hello, so yeah, congratulations to both presentations. I had a question for the second one. So I was thinking of how, because in areas where there has been a high bombing, that means also that the general population have died more, probably. And therefore, how could this change the composition of the people in your sample, and therefore be different and then affect the infant mortality as well? I'm not sure how to think about, but yeah, maybe.
Thank you so much. One more.
I have some questions and comments for William, and I'd like to thank both speakers for their excellent talks. I also have done some work with the University of Cape Town on trying to measure vulnerability at household level. And I agree with you that although poor children are generally more vulnerable, there are many non-poor children who are vulnerable to climate change and many poor children who are not vulnerable. And we try to add in some demographic variables such as younger children are more vulnerable to floods. They're smaller, they can't run away as fast, they can't swim. They're more vulnerable to, particularly where there's poor sewage, to the disease because their immune system's low. Disabled children are more vulnerable. Children who are involved in labour, which is outside, such as subsistence farming, are vulnerable to drought. So I think although the child poverty thing in general is good, you need to tweak it quite a lot to make it specific to the vulnerability and extend beyond poor children as well, because there are other factors. It's not a one-to-one mapping. We use the MDAT database, and I take your points about the problems with that. I was a bit surprised by your findings on drought in Uganda, because the poorest area tends to be in the northeast Karamoja, and that's had significant droughts. So I was surprised there's less vulnerability, and I wondered why you thought that was.
Thank you. Let's give them a chance to answer, and then we can continue.
Thank you. So about the first one, so water contamination was available just for the second wave of survey, so I cannot do nothing about the 2012 and 13. OLS, because my supervisor asked for it. Just as straight, yeah.
This is going online.
No, I mean, they said just run it. I was okay, so I consider I did, it's there. I can remove it, thank you for that. The negative binomial overinflation, I mean, there are not as many zeros as one can think, actually. So I was afraid of that as well, but the mean is not, I mean, it's significantly different from zero. So that is still something to worry about, but in a different way. And about the change in population, I focus on after the war. I don't know anything about before the war. I just, whatever happens, so children that were born is after the war. Opening of the dams is after the war. So whatever happens before that, I don't know. There is no data about that, so I wouldn't know. The only data that I looked at before the, not even before the, is right after the war, whoever came back. If they came back in the same municipality, just to see if they actually live in the same heavily bombed region. So that's it.
Thank you so much, Dave. I'd be really interested to look at how the different components and how those were decided, which ones to kind of add in, and what sort of statistics we used to kind of define that. I've sort of found it hard in this process to sort of some based on sort of hypothesis, but not necessarily data substantiated, and understanding more about those methods would be very keen to do that. With Uganda, I think so. The survey that we used was actually following a very, very severe year of drought. So almost the entire country was affected by drought, and I think that maybe links to some of the thinking that we've been doing about how we define that exposure, and whether or not that should just be the year before, or whether that should be a period average longer than that. So maybe 5 years if we're looking at, and then whether based on historical data, or whether we try and bring in projections to look at areas that are likely to be affected in the future, and trying to match up and define exactly how these data can be most useful, I think is still a process that we've been sort of discussing this for a long time now, and still haven't decided on which pieces of data. We know there's something that can be done with it, but how it could be most relevant is still a work in progress. And I think that issue points to one of the limitations that we've found with just basing it on observation.
Thank you both so much. Okay.
Thank you very much. Simple question, really. I mean, it's amazing all this work is going in. I'm interested in the ability of state, like in Nigeria, it's a federal system, so I'm thinking about the infrastructure development and something at the level of a state government as opposed to a national government, even something, what proportion of budget goes into climate change preparedness. Might that make a difference, and can that be worked into the subnational profiles that we're trying to develop across the region? Because it's one thing to say the family vulnerabilities, but states also have a responsibility. And how do we reflect those in the models in terms of people are going to run, but where they're going to run to? Yeah. And so is this something UNICEF colleagues in country can help us with, trying to get subnational policy relevant data, at least on shares of spending that go towards important things, because we can't model everything. We have to have assistance from colleagues there. So that might be something we would need UNICEF to work with.
Do you have something? Can I add? Actually, it's a very interesting question, because now we are working with colleagues in Nigeria country office and the government. It seems like they don't have any data related to climate change and global warming, like literally nothing. And one of the things that they are trying to do now actually is to create demand for the data in country. We are not talking about outside people. So now we are including some of these questions in Mix Plus survey, which is going on currently. It's basically, we are continuing, I will not spend, it will take me time to explain, but it's basically we are using Mix subsample to continue interviewing people over the phone. So we are trying to introduce at least something for start, and then we will see how it will go. But yeah, it's really, I was also very surprised, honestly, that there is nothing there. So yeah, let's see now how it will go. Will, do you have something to say?
The
No?
Kenya Statistical Office, just to respond to that, the Kenya Statistical Office has a question module it includes in its panel survey, asking people how they've been affected by climate change and extreme weather events. So that might be a useful model for Nigeria.
Thank you so much.
One online question.
One online question. Ashraf? Let's give colleagues a chance to ask, please.
This one is for Will. When you estimate the model, are you controlling for co-funders or use multi-level approach with random intercept? That's the first part. The second part is it possible to set up a model with repeated measures of both poverty and flooding / drought? Do you want me to repeat?
Yeah, could you just repeat that second one?
Yeah. Is it possible to set up a model with repeated measures of both poverty and flooding / drought?
So to the first point, we have done that. It feels strange talking to an empty, talking to the screen. We did do that, but I think that.
Look here, Will.
Yeah, we did do that, but I think I've stepped back from that. I think that by estimate, I think it depends where the direction of the work, and it might be, we might come back to it as a next step. If we're trying, by including covariates, actually we do include some covariates or potential confounders. We include, actually no, I think it's purely descriptive, because we don't want to control for any of the potential mechanisms that children are more affected. We just want to disaggregate by whether or not they're vulnerable. And by controlling for any of that, then we are potentially explaining some of that, which, as from a descriptive and a resource allocation perspective, we're not interested in doing. I think that where we would potentially bring back the multi-level modelling would be as if we wanted to look at small area estimation, and where if we wanted to smooth data across space. And that is something that we've been trying to explore using machine learning and the different approaches to do that, and definitely are very keen to do that. But I think that it's really important to kind of decide whether or not you're asking a causal question, which was asked in the second presentation really nicely, or whether, from our perspective, it is very much a descriptive exercise. I think that the issues with doing the longitudinal analysis are that the surveys are cross-sectionally representative, and so we don't have repeated observations on individuals. We only have repeated observations at aggregate level. So we would be able to look at areas that were more affected and how rates of vulnerability had changed over time, and depending on levels of exposure that had occurred. But you'd be quite underpowered depending on what the surveys are only representative at admin 1 level, so you need a lot of countries to do that type of analysis over time. But it is possible, but that would be more of a causal question.
Unfortunately, he said he couldn't hear a word.
Oh my God!
But he said
We will have a recording.
he would ask you in New York later, and why. Yeah.
Okay, and we will have a recording just to remind. One more question. Short one. Short one.
Okay, I have the mic, so I can ask. I have 4 questions. Okay, I can discuss them with them separately.
You can ask all, and then Will can answer one.
Okay, so both presentation I really liked, and I've been in touch with both of them in the past, so I'm a bit aware, not too much, a bit aware of your research, so I'm very eager to learn more. First question goes for both of you. The criteria of selecting the buffer zone. So William selected 5 kilometers and Elsa in the other 6 kilometers. I heard you, Elda, is explaining something, but I would like to know more why 6 kilometers. I may understand for Elda why, but for William, I'm not expert on floods and anything, so I am sure you know much better than me. But going for all the clusters with 5 kilometers, why? Just a question. Is it? I assume it's not the same in urban zones and in rural zones. Just a question. And then for William, Nigeria 2018 DHS. How can mix 2016, 17, and 2021 can help you on this research? I would like to know more. And I have a boomerang question for you, William. In the morning, you made the question about 10 by 10 kilometer spatial resolution. And now I have the question, why you use states for Nigeria? So I know that MIX and DHS, both of them are representative at the state level. And I know you are more concentrated on on exposure and vulnerability, where it's more expressed. But I saw the capital city and Lagos, so the 2 biggest cities in the country, they were in white. In the map, they were in white, so there was no exposure and no vulnerability. And I assume because of these 2 big cities. But what about the children that are living around? Sorry.
I knew this was a big mistake. So we have a break now. But I need to ask, do you want to stay at least to give Will a chance to answer one question? And I'm serious now. Okay? Everybody okay with that? Okay, good.
Does also want to go?
Do you want to answer some questions?
I guess
I don't know how many questions.
on the buffer zones, I guess that was, I hadn't even considered the urban-rural split, so that would be an interesting one. Our goal was to offset the displacement, so we wanted, and second, so we knew that the clusters would be displaced by 5 kilometers in rural areas up to, and so if we classified and the cluster had been moved away out of the flood zone, we wanted to make sure that they were considered in. So but I hadn't thought to do that differently by urban and rural. So that would be definitely something to do. And then the other questions were the mix. Yeah, how can we use the other surveys? I think I haven't really thought too much about that temporal element to, and that would be an interesting case study where you've got lots of data across time points. Repeating the exercise and I suppose repeating the exercise would be an interesting one. And also kind of the points that were being made about longitudinal, long-term prediction as well, maybe into the future where you've got lots of data points over lots of, you've got a long kind of time series. On the small area estimation, so this is something, and I'm keen to talk to as many people about this as possible in these next 2 days. We have estimates of uncertainty at the state level, but as soon as we go lower than the state level, we don't have any estimates of uncertainty. And some people might say, some people have said, and I've spoken to some people but you need to provide something to support decision making at a lower level. So, but up until now, we've been a bit hesitant to do that, and we are exploring methods to go down to one level below that because I think more disaggregated decision making would be better. But we want to do that with quantifying that uncertainty. And so that's kind of our goal, our next step. And I suppose, so I think that the dimension that we haven't considered in the metric at the moment is the population size. And so currently all states are considered equally depending on exposure and vulnerability, when actually depending on the proportion of exposed and vulnerable, there could actually be more children in one particular state. So I hope that our bringing that in would kind of help with that. But the points about large scale, like mega cities, and the point and the question that was raised in the first session around the kind of how do we think about urban areas with high population density, I haven't thought about that enough, and I think it's a really important point, particularly also because I'm still not sure that the levels of the population size of that vulnerability in Lagos will be captured. Hopefully, if we bring in that population data, it would be, but currently it's not. So yeah, it's a really good point. 6 kilometers.
Do you have something to add?
I mean, not really. The reason why I just took the 6 was because of the graph that I showed you. I also tried with the 3 kilometers. I didn't have enough power because I didn't have enough data. I tried with 5, still works, still robust. Also with 8, still the same result, but lower infant mortality. So which is consistent.
So thank you, really great presenters. I really enjoyed, and I'm glad that we have a little bit more time because only 2 presentations in the session. And thank you all for questions. Thank you, colleagues online. Hope you can see me. Enjoy the break, and we will be back soon. So thanks again.